Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at one of the applications of the concept of conservation of momentum. And this, of course, aspect of conservation, as I said from previous discussion, is going to be encompassing a range of ideas which we have in one way or another looked at, and the concept of basically different topics. And this is going to be, as I've said, entailing one of the aspects of momentum, whereby we're going to have a conservation of momentum. And of course, we have spoken about the concept of conservation of energy, conservation of electric charge, conservation of electric current, especially concerning the Gustav-Kirchhoff's law of the electric current at a junction, which is going to be described in terms of this specific aspect of conservation. Now, they basically mentioned that the concept of conservation means that whatever goes into the system is whatever that is going to come out. And in this particular case, then therefore, we are going to look at momentum in this specific perspective. Now, therefore, I'm going to consider the mass of two specific objects, and we're going to see that these specific objects are going to be obeying the law of conservation of momentum before and after a collision. Now, in our previous discussion, I had basically mentioned that we have two types of course, collisions, which are going to be elastic and inelastic collision. Now, in this particular discussion, I'm going to consider two specific objects which are going to undergo elastic collision. And in our previous discussion, I basically mentioned that one of the characteristics of elastic collision is that energy is going to be, there's not going to be exchange of energy. And therefore, we are going to expect that if we have two bodies of masses m1 and m2 given as such, and if this body are going to be, of course, undergoing this specific event of collision, we're going to see that we can have the momentum of this specific body for the first mass given in terms of its initial mass, or rather its mass and the velocity given as such. And we can as well give this momentum of the second, of course, mass given in terms of its product of mass m2 and its velocity given as such. And in this case, where we are going to see that basically we're going to have its initial velocity components given in terms of course, this representation for v1 for m1 and v2, and let's have this one as for m2 we shall have v2 being its respective velocity component. And of course, we're going to have their respective masses given in terms of m1 and m2. But if we consider the final velocity after collision, we're going to have this specific, of course, notation for the final velocity. For m1, we're going to have v1 prime, and for m2, we are going to have v2 prime given as such. So if we consider the aspect of momentum, then therefore it can be represented using this specific, of course, representation which I've given for 1 and 2 given as such. And as well, we can consider the aspect of their kinetic energy, of course, which can be given in a specific way. So in a sense, we're going to see that we can describe this specific aspect of a collision, of course, in consideration of the event before and after collision, whereby the initial momentum can be given in terms of the momentum before collision. The sum of the momentum before collision can be given in terms of m1 v1 and m2 v2, which is equivalent to the momentum after collision given in terms of m1 v1 prime plus m2 v2 prime given as such. So in this case, we're going to see that momentum basically is going to be after and before collision is going to be given as such, and as we said, this is going to be conserved given as such. So therefore, we can describe the different elements of velocity, kinetic energy, and perhaps a relative velocity in terms of this specific aspect of conservation of momentum, whereby we're going to see that particularly for the case of elastic collision, we're going to see that the kinetic energy of these specific particles as well is going to be conserved. Therefore, we can have a fashion of a representation for the relationship for kinetic energy before and after collision using this specific representation from our previous discussion, whereby we see that kinetic energy can be given in terms of half mv, the square of velocity given as such. And this is going to be, of course, giving us the product of mass and the square of the velocity. Therefore, for us to give the kinetic energy of the first object, which is going to be P1, this is going to be given in terms of half m1 v1, the square of that, plus the kinetic energy of the second object, which is going to be given in terms of half m2 v2, the square of that, given as that one. So if it's going to be conserved just like momentum, then therefore we're going to expect it to be the same for the, of course, the square of the f prime, v prime, which is going to be given in terms of that one. So we're going to have m1 v, half m1 v1, the square of that one prime given as such, and I have m2 v2 prime squared given as such. And this is going to be giving us the concept of conservation of kinetic energy in this specific system for elastic collision given as such. So from this specific relationship, we can see that we can have a particular case whereby we're going to have m1 into v, which is going to be the initial velocity minus the final velocity after collision for the first particle described as such, is equivalent to basically the mass of the second particle and its specific, or of course a particular velocity given in that, in terms of that specific difference given as such. And this is going to be the same for the kinetic energy, which we have described in terms of m1 into v1, the square of that one, minus v prime, the square of that one, is equivalent to m2 into v2 prime minus v2 prime. So these are going to be the respective squares for kinetic energy of those two specific components for mass 1 in this specific case and mass 2 respectively. So this is going to be giving an implication that basically if we try to analyze those specific equations and they simplify for the two, and if we have the ratio between kinetic energy all over this specific aspect of momentum, we're going to have this particular relationship whereby we're going to have a v1 plus v1 prime is equals v2 plus v2 prime given as such. And this is going to have an implication that relative velocity before collision is equivalent to relative velocity after collision. And this is going to be giving us the relationship between two colliding objects in elastic collision concerning their specific momentum, the kinetic energy, and relative velocity given as such. So this is going to be forming a final part of this specific discussion. In our subsequent video, we're going to look at some evaluation sets which are going to be assisting us in trying to understand better this aspect of elastic and inelastic collision so far as conservation of momentum is concerned, and the whole aspect of collision. Now in our description box, I'm going to put a link which is going to be consisting of similar videos under the same topics, and this is going to be assisting us, of course, having an general view of this specific topic as I've said. So that is it for now, guys. By God bless you. Catch us in our next video.